Boys and girls, it's Miss Basell. Today we are starting topic 4. We're going to be working with multiplying decimals for the next couple weeks. So we are on page 165. We're looking at lesson 4.1, multiply decimals by powers of 10. So I will wait for you if you need to go grab your volume 1 textbook. Otherwise, we're going to start actually on page 166. And our guiding question, our essential question that's going to guide us through this lesson is what patterns can help you multiply decimals by powers of 10? So let's real quick review what powers of 10 are. So we talked about this a couple of chapters ago. If we talk about a number that is 10 to the first power, we're talking about the number 10. 10 to the second power is the number 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. And you got it. 10 to the sixth power is 1,000,000. So the power tells you how many times you multiply 10 times itself to get this product. Another way to look at it is the exponent tells you the number of zeros that are with the number 1 in the product. And the very last one that I didn't talk about was 10 to the 0 power. And 10 to the 0 power is simply number 1. It has no zeros with it. So those are the power of 10s that we worked with. All right, so we have a situation with a baker who has a 10-pound bag of pecans and a 100-pound bag of flour. How many cups of each ingredient does the baker have? So we're looking here at the flour, 3 63/100 cups per pound, and the pecans, 4 2/10 cups per pound. Our 5th grade helper is thinking that multiplying decimals is like multiplying whole numbers. You can use multiplication to join equal groups. So the visual learning takes us through using patterns to find the products. Now, I'm going to go back to what our little 5th grade helper said, and let's refer back to whole numbers. So when we multiplied a whole number, like maybe we had 52 and we multiplied it times 10, if you remember, we just multiplied the whole number times 1, and we annex the number of zeros in our multiple of 10. So we would annex 1 0 to get 520. Well, if we applied that same step to decimals, look at what happens. We would be writing our 3 63/100 and annexing that 1 0, but we have a small problem because 3 63/100 is equivalent to 3 630 thousandths. So we didn't make it 10 times greater in value. So that is not going to work with decimals. All right, so now let's look at what's going on in the book. So they're showing us that we can use patterns to find the products. So if we multiply our 3 63/100 by 10, or another way of saying that is 10 to the first power, they're showing us that we get 36 3/10. And the way that this works is we're actually moving the decimal one place to the right for each power of 10. So if you move the decimal to the right one place, you get 36 3/10. All right, let's take 3 63/100 and multiply it times 100, or 10 to the second power. So if we follow that same philosophy, we're going to move the decimal point 2 places to the right. Now that's going to put the decimal at the end of the number, and it's going to give us 363. Okay, and if we take that same 3 63/100 and we multiply it times 1,000, or 10 to the third power, then we're going to move that decimal 3 places to the right, which means, wait a minute, we have to annex a 0, right? And if we do that, then we get 3630, and we wouldn't put decimals at the end of these numbers. So we'd get 3,630. All right. So in the case above, the baker has 363 cups of flour. Now, we would need to look at the pecans as well. So if we look at those, the pecans were 4 2/10. So if we multiplied that times 10 to the first power, or 10, we move that decimal place one place, and we would get 42 cups of flour. 42 cups of pecans. Okay. All right, so that's how they worked out this problem. All right, so they continued the patterns. All right, let's just put this in action and see what happens. All right, we have a convince me problem at the bottom of page 166. We're going to complete the chart, and then we're going to look at the patterns of the placement of the decimal points. All right, so if we start with 1 275 thousandths, and we multiply it times 10 to the first power, or times 10, we move that decimal one place to the right. If we do that, then instead of having the whole number 1, we have the whole number 12, and then 75 hundredths. Okay? If we move that decimal 2 places to the right, when we multiply it times 10 to the second power, or times 100, that decimal now ends up between the 7 and the 5, so we have 127 5/10. And then if we multiply our 1 275 thousandths times 10 to the third power, we move that decimal 3 places to the right. It puts it at the end of the number. This is going to make it a whole number, so we don't need a decimal there. And we get 1,275. All right, let's look at the next number, 26 14 thousandths. If we multiply it times 10 to the first power, or times 10, that decimal moves to the right one place to give us a larger number, and our whole number 26 becomes 260, so that makes good number sense. And then we have our decimal point and 14 hundredths. If we move it 2 places, for when we multiply it 26 14 thousandths times 10 to the second power, or times 100, that decimal point ends up between the 1 and the 4, and it makes sense because now we have 2,601 4/10, which we're getting larger in value. The whole numbers are what I'm kind of looking at to gauge that with some number sense. And then if we take our 26 14 thousandths and we multiply it times 10 to the third power, or times 1,000, we move that decimal 3 places to the right, and that makes one large whole number, 26,014. All right, and the last one, we have the number 4/10. If we multiply it times 10 to the first power, we're going to move that decimal point one place to the right, and we have the whole number 4. If we start with our 4/10 and we move that decimal point 2 places to the right, well, we're going to end up annexing that 0. So that gives us the whole number 40. And I bet you can guess what our next number is going to be. If we multiply times 10 to the third power, we're going to move that decimal point 1, 2, 3 places to the right, which means we need to annex 2 zeros. And that's going to give us the whole number 400. And with your number sense, you can see that the whole number parts of each number get larger by 10 each time. All right, so you're moving the decimal point to the right one place for each power of 10. And on the ones where I annex zeros in the yellow, you can see why we needed to annex some zeros. All right, let's look at some problems on page 167. Top of the page. All right, we have another example where the little girl says, what pattern do you notice in the products? And this example says that you can use patterns to multiply by decimals. If we multiplied 3 63/100 by 1, by 1/10, and by 100, what's happening? So 3 63/100 times 1 stays itself. And that's because of that identity property of 1. Any number times itself equals itself. All right. But if you multiply 3 63/100 times 1/10, oh, you're going to get a smaller number than 3 63/100. So I noticed something different happened here. If I'm multiplying times a decimal number, look at what happened. We went from 3 63/100. We're going to get a smaller number because we're multiplying by a smaller number. So instead of multiplying by a power of 10, where we move the decimal to the right, we're multiplying times a decimal. So we're going to move the decimal to the left one place. So that is where we get 0.363 for 363 thousandths. All right, same thing happens here. We're going to multiply 3 63/100. Here we multiplied it times 1/10. Here we're going to multiply it times 100. So we're going to multiply, or we're going to move the decimal to the left, 2 places to the left. So the decimal is going to go here, right? And we're going to need a 0. So that's going to be 0.0363, which gives us 363 10,000ths. So the difference between what we did here was we were multiplying by whole numbers that had a value of 10, 100, and 1,000. But here we were multiplying decimals by numbers smaller than 1. So the decimal moves to the left so that we get a smaller product. All right, that's going to be very important to go back and look at those examples at the bottom of page 166 and here at the top of page 167. All right, so let's look at number 2. 2, 3, 4, and 5, all we have to do is find the product. So the main thing we need to look at is what are we multiplying by? We're multiplying 9 thousandths times 10. So we're going to get a number larger than 9 thousandths. So that means that decimal place needs to move to the right one place. That is going to put it, oops, don't need 2 zeros. Let me start with where my decimal is going. My decimal is going right before the 0, 9. So I put my 0 in my whole number place, and I get the product 9 hundredths. All right, 3 1/10. We're multiplying it times 10 to the third power. So we need to move that decimal place 3 places to the right. So I'm going to move 1 place, 2 places, 3 places. So I'm going to need to annex that 0, which is going to give me 3, 1, 0, 0. I'm not going to put the decimal behind it because it's a whole number, but I do need to put in my comma in the thousandths place. So 3 1/10 times 1,000, or times 10 to the third power, is going to give me 3,100. All right. 62 thousandths times 10 to the second power. All right, I'm going to move that decimal 2 places to the right because my factor here is larger than 1. 10 to the second power, I'm going to move it 2 places, 1, 2. So my decimal is going to end up between the 6 and the 2. So I get rid of all the decimals before a whole number, okay? And I get 6 2/10. This one's going to be a little bit different. If you notice, we're multiplying this decimal times a decimal number, which has a value less than 1 whole. So we're actually going to get a smaller product. So in this case, the decimal needs to move to the left, and we're multiplying it times 100. So we need to move it 2 places to the left. So that means we're going to need the decimal and a 0. So we would need a decimal and a 0, the 1, the 2, and the 4. I need a 0 for my whole number. So that gives me 124 10,000ths. Okay, so does everybody see why number 5 would be different than 2, 3, and 4? It has to do with the fact that we are multiplying times a value less than one whole. And we talked about using scaling in less than 8. So that should help you think about that. All right, numbers 6 through 15. You guys are welcome to pause the video here, do the work on your own, and then check it. Or if you need to go through it with me, we can go through it however you want to. You can manipulate the pause button. All right, so I'm going to multiply 42 3/10 times 1. So if you need to go out to the side and move that decimal, you move it one place to the right. No, my bad. I'm multiplying it times 1. Any number times itself is itself, so that one just stays the same. All right, 42 3/10 times 1/10. That decimal is going to move one place to the left. Remember, 1/10 is less than one whole, so I'm going to get a smaller product. So I get 4 and 23/100. And then I'm going to multiply 42 3/10 times 100. That means I'm going to move that decimal 2 places to the left, and I get decimal 423. Put my 0 out front, and that gives me 423 thousandths. All right, number 7, we're multiplying by 10 to the first power, 10 to the second, 10 to the third. That means I'm getting larger numbers. In order to do that, my decimal needs to shift to the right for each power of 10. So 86 thousandths, if I'm multiplying it times 10 or 10 to the first power, that decimal is going to shift to the right one place, and I'm going to get 86 hundredths. All right. For 86 thousandths, if I multiply it times 10 to the second power, that decimal is going to shift to the right 2 places, and that is going to give me 8 6/10. And for 86 thousandths times 10 to the third power, or times 1,000, that decimal is going to shift, you got it, 3 places to the right. It's going to put it at the end of the number. I get rid of all those zeros in front of my whole number. Don't need a decimal at the end of a whole number, and I get 86. All right, number 8. If you're multiplying 63 7/10 times 100, hopefully you shift that decimal. We're going to make a smaller number, so you're going to shift it 2 places to the left. When you do that, it's going to put it in front of the 6, so you get 637 thousandths. And that would be 1/100th the value of 63 7/10. For number 9, you're multiplying this decimal times 100, 10 to the second power. That means that decimal is going to move 2 places to the right. So what that means is we need to annex a 0, and you get 56,370. Number 10, we're multiplying the decimal times 10 to the fourth power, so we're getting larger. That decimal needs to move over 4 places. It only has 3 places to go, so we need to annex a 0, and we get 3,650. Number 11. Number 11 is a little different. We're multiplying that decimal times a decimal, so my product's going to be smaller than if I multiplied even by 1 whole, so I need to move that decimal to the left. 1/10 tells me I need to move the decimal 1 place to the left. That is going to put the decimal in front of the 5. It's going to give me 502 thousandths. All right. Number 12, 94 6/10. You're multiplying it times 10 to the third power. That means we're going to move the decimal to the right 3 places. We can only move it 1 place, so we need to annex 2 zeros. We get the product 94,600. All right. When we multiply 9,463 10,000ths times 10 to the second power, the decimal is going to move 2 places to the right. That's going to put it after the 94. So we get 94 63/100. Number 14, you're multiplying a decimal times a decimal, so the value is going to be smaller. You're going to move the decimal to the left. So moving the decimal to the left puts it out in front of the 0. So we get 678 10,000ths. And our last problem, we're multiplying a decimal times a decimal. So that our decimal point needs to move to the left so our product is smaller. When we do that, we're multiplying times 100th. So we move that decimal point 2 places. That's going to put it between the 6 and the 8. So we get 6 and 817 thousandths. All right, boys and girls. So today we were looking to see how we could multiply decimals by powers of 10. The key thing we need to know is that if we're multiplying a decimal number times a whole number, we move the decimal to the right, so we get a larger product. We move it to the right for each power of 10. If we are multiplying a decimal times another decimal, then we need to move it to the left. So we'd move it 1 place to the left for 100ths. We'd move it 2 places to the left if we multiplied by We'd move it 1 place to the right if we multiplied times 1/10. We'd move it 2 places to the left if we multiplied by 100th. We'd move it 3 places to the left if we multiplied by 1,000th, and so on. All right, so you have bookwork, or you can go to your Google Classroom resources under Lesson 4.1, and you can do the Practice Buddy online activities. The choice is yours.